Hello, everybody, and welcome to Single Pane, Episode 3, Agents and Assistants, except actually not. So, Mya, do you want to tell everyone what we're actually going to be talking about?
I don't know, maybe we should go through intros first.
Okay.
Yeah, so we I guess for new people joining us, my name's Mya. I'm the founder of C8 Labs. I was recently laid off from KKI, so I've got kind of all the time in the world to myself right now. Kind of sucks given the market we're in, but very much looking forward to my next opportunity. So it's a little bit about me. A lot of what we're going to talk about today is the project I've been working on. So
Yes. Yeah, we're very much rooting for you. Yeah, I'm Josh. I'm a developer advocate and open source advocate at Altinity. So this is our own podcast, though, right? This is not the opinions of my employer here. Yeah, so we're going to talk about this project that you've been working on that you kind of been hiding from me, right? Like we talk a lot about these cool things that we're working on, and just like out of nowhere, you pull out this like insane story of this project. And I was like, yeah, so when are you doing that as a conference talk? Which we're all waiting for, but we're going to get a little sneak peek today.
Yeah, and there's kind of been some like really interesting history around it, which is why I've largely held off talking about it to people kind of outside of like the need to know circle. I've had a number of conversations with folks when I was kind of still back in stealth and not really willing to kind of talk publicly about it. And then I got kind of like a really interesting piece of advice, which was if you're in stealth because you're afraid somebody else is going to take your idea and run with it, there's not enough intellectual property to your idea worth turning into a product, right? And I'm like, well, isn't that like just kind of like a little hit a little too hard home, right? And I kind of get it. Like there's some value to having a project that is kept a little bit under the covers, but where this project very much stemmed from was kind of my experience with search and rescue, kind of seeing the ways that we kind of use ecosystems today. Then I would say like late in the fall kind of had a few hard conversations with mentors and decided to kind of shelve some of it. So going to find full-time work again really kind of put a damper on a lot of it. It's why I really haven't talked publicly about the project I was working on, even though I actually nowadays think it might be helpful. But it's to kind of give. Go ahead.
Yeah, we're being a little bit coy about what the project is, right? So we put it in the title. It's drone. It's sort of an autonomous drone to assist with search and rescue.
And drones today are used pretty extensively, right? Like it's not just an autonomous drone, but it's a means of being able to bring some more smarts out in the field with us.
Yeah, that's awesome, and I'm so excited to hear more about that. Can you start by telling us like how you got involved in search and rescue?
Man, it was kind of an interesting experience for me. I was going through a lot of like medical training back in, I want to say this was like 2020, 2021. So basic life support, emergency response in the event of like active shooter drills. I was doing a lot of it for local community support. And when I was at one of the trainings, that's when I kind of got introduced to the search and rescue organization that I got involved with. And just everything they kind of talked about really resonated with me. Like I did a lot of scouting growing up. I knew my way around a compass, around GPS, around land nav, you kind of name it all. I was very, very familiar with it. So it felt like something I could sit down and kind of pick up easily. And I wasn't wrong. Got involved with the group for a few years. More recently decided to kind of take a step back away from that group as I went about starting to consider an active move out of Texas. And so that was kind of like my story getting into it. A lot of it's just skill sets that I already had access to. And a lot of things was a lot of it kind of fell more from the perspective of how do I kind of take these skills I have and put them into more practical use? One of the things that they talk about is when you know CPR, you're highly unlikely to ever need to put it into practice. And so kind of having that skill deteriorates over time. And so finding active ways to help and support where you can is really useful because it helps you stay on top of those certifications. So that's kind of just like my story of like how I got into that space. Once I was there, it was kind of interesting. I latched on to tech, so it was really easy to kind of like look around, see the technologies that we were working with, and then start to kind of just let my brain shut on it in the background of like, where's some of the things that we have problems with. For people that kind of don't know, like very few organizations actually use drones these days. Like there's a good number of them still, but drones tend to be fairly expensive. They need to fly at a minimum altitude according to the FAA, sorry. And so a lot of times, like the visibility that we get on cameras isn't great. You can't really run those videos through ML models when you're talking about like, hey, I want to try to find like a backpack in the middle of the woods, right? At 150 feet in the air, you're not going to get much resolution to be able to tell if it's a backpack or a rock. There's a few data sets out there that we'll probably talk about later in this that can kind of talk a bit more about this in depth, or at least show it.
So you mentioned looking for a backpack. What are, I guess, for those not familiar with the space, what would be some of the other activities that search and rescue for, like just the humans doing it?
Yeah, so for search and rescue, a lot of times we're looking for missing persons, right? I don't want to get into like case details or anything like that.
Of course, yeah.
But generally speaking, you're either looking for a missing person who recently went missing or a missing person that has been missing for a while. In the latter case, we're quite often trying to look for bones, look for kind of interesting smells when we're out in the wild, things that are indicative of like a body nearby. But we also respond in kind of like active events, right? Like I think it was like a month ago, we had the floods here in Texas that claimed a good number of lives. We had similar types of issues out east in like the Tennessee, Kentucky, Georgia area, all where they got hit with hurricanes and whatnot. And effectively like, or North Carolina was the other big one there from what I remember, where like entire cities were swept away, right? So quite often we're responding in those events. A lot of the organizations that I was looking at with this project roll up under FEMA, so the Federal Emergency Management System, largely volunteer-based 503Cs, yada, yada, yada. That's kind of just to give you the scope of the operation. So yeah, very much dealing with kind of real-time emergency management and response, but then also kind of cold case investigation, extra legs on the ground when we need to canvass a several kilometer area looking for something. Sometimes, like I said, it's a person. Sometimes we're just looking for a backpack, right? And that's not like somebody lost their backpack, so they called us in. It's we're looking for a backpack, hoping that it gives us a clue to where to find a missing person. There's a lot of like training that there's a lot of branches you can kind of go off there. And drone search and rescue is one of them, but currently kind of requires a whole bunch of training around being able to fly the more expensive drones, right? That training takes time, it takes money, it takes expertise. It's harder to get people to be able to volunteer for. A lot of people are interested in flying drones, but getting that FAA certification can be very hard. And yeah, at the end of the day, you're operating like a $10,000 drone that you're flying fairly high up. So the big question is kind of how do we make that more effective, right? How can we actually start to leverage systems and models in offline environments where you don't have necessarily live access to cloud-based resources, right? I think a big thing that people overlook is that in a lot of these disaster events, you're usually dealing with lack of cell phone signal, a lack of an internet connection. And so they're just like, oh, just like call out to the cloud. And the answer is, well, kind of, right? Like you've got things like Starlink, which I've heard mixed things about. I don't want to get into it here. But that's one way to kind of get satellite-based internet access in the event that you need it, but you're still dealing with a rather restrictive bandwidth. And then you're dealing with remote machine instances, things like that. You have to process and wait. And sometimes you have to queue it up and wait for a response. Sometimes you can't really get a response back immediately. So the network connectivity is very unreliable in those situations, right? And so being able to work in an offline capacity is very important. I think I've covered kind of a lot of the context there.
Yeah. Yeah. So do you want to introduce us to kind of what you specifically have created?
Yeah. So kind of building on that, right? Like, how do we kind of take these fairly large, fairly complicated systems, break them down into a smaller, more manageable ecosystem that pretty much anyone can pick up and work with off the shelf. And then also make effective use of kind of like edge computing. So my goal was, let's start with the drone, right? Drone is 10 grand. How do we go from something like that to, let's say, like $1,000 DJI? Can't use DJI because government contract reasons, but just as a rough like pseudo example of what we're trying to analogize it to, right? In practice, you can swap the drone out for whatever 4K video drone you have at hand. The important thing is just that it can take 4K video and then transmit it over to an actual, like, we'll call it a remote server, a local server. From the drone to kind of like the control instance, mine kind of currently goes through my phone, right? So controlling the drone is from my phone, and then I can send the video stream from my phone via something like RTSP or RTMP, which is real-time media protocol or something like that, which allows you to effectively just live stream, capture, and record a video feed. So that information gets sent along to what is currently my Mark III instance, built on top of a Raspberry Pi and some accessory boards, we'll call them, where it can do computer vision and take that video stream, manipulate it in real time, do object detection, recognition. And then when it locates a piece of information, being able to identify, like, hey, like at this set of coordinates, we were able to find a backpack, or at this set of coordinates, we were able to find something ambiguous on the ground, right? Maybe we don't get a clear enough picture of what it is and can't get closer. But the big benefit to going to something like the DJI drones is that, or not the DJI drones, but the smaller drones, is that you don't need FAA clearance to fly them. For smaller drones under, I forget if it's a certain size or if it's a certain propeller size or whatnot, you actually don't need kind of FAA clearance to fly it. And you can fly that at much lower altitudes, right? And so when you're doing search, being able to gather video feeds from lower altitudes is important, because then you can get finer detail that you weren't getting at that higher altitude from the higher level drone. So this kind of started the start to it, right? Because a lot of it's like, how do I kind of build this in pieces, right? I don't want to go kind of full to the wall. That was about where I ended back in the fall. Was cool. We've got an object identified. We've got it notified on somebody's phone screen that you can actually see, like a backpack and whatnot. What do we do with that information? Well, when I was doing some of the more active search and rescue involvement, a lot of that information was stuff that we were relaying over radios. And the radios were, we'll say, again, kind of fairly reliable. The challenge with the radios, again, is that, like, a lot of times they were just built on, oh gosh, what's that band of signals? GMRS, general. It's a general radio station, effectively, that's used by a lot of walkie-talkie bands. But there's some bands that are exclusively used by these higher end devices that allow us to kind of transmit information. There's certain ones too that are encrypted. And so the kind of nice thing about this was, like, cool, we had a radio in the field, so we could just radio it back. Well, call it a long shot or something like that, but those radios, as soon as you kind of had loss of line of sight, it was really hard to kind of get a message back to command. So sometimes you would end up having to play like piggyback or phone or what is it called? The game when you were in high school or middle school, when you would whisper in someone's ear one thing, and by the time it made it all the way back around to you, it was something completely different, right? So you would relay a message to one team, that team would confirm the message back to the original team, then relay it back to headquarters if they could, or find a path there. So I wanted to find a way more recently to be able to have that message kind of like automatically ping back where we can, but also be able to leverage kind of the larger drones that we already had access to. Because like I said, some organizations had the larger drones that had to fly up at 150 feet, but not all of them did. And so that's where the low raw component kind of started to come in, where I was like, okay, like I've got a set of coordinates which are in, we used UTM coordinates, which are 8 character designations effectively. The world is broken up into a bunch of small grids. And then depending on where you are in the world, you're in a certain grid. And that coordinate system, instead of being represented in decimals for degrees, minutes, radians, it was just represented as kind of a 15 to 16 digit string, right? So made it significantly more compact and could be sent over the wire relatively easy. Plus whatever then the message
the whole
payload
world into a battleship grid, basically.
Yeah, like I think if you looked up, I think I was like looking this up the other day, where it was like UTM coordinate systems, and I was trying to find like a good representation of it. And if we actually pop over to this, just to kind of give you an idea of like what this relatively looked like, you would effectively system. Really want to find a string representation of it, because it's actually pretty succinct. It makes it really easy to communicate over a radio.
Okay, it's like hex codes for a lat long.
Effectively, yeah. Like that's actually kind of a great way to think about it. Is like you can kind of narrow in on the specific point in space. And just it uses a much more succinct form. And you can take, UTM coordinates, convert them to decimal coordinates. You can convert them back to UTM, like with some simple math and equations. But the idea was, now we've got kind of this nice, like succinct packet of, we've got the coordinates, we've got what we found. What do we do now, right? And so that's where I started looking at Meshtastic. Are you familiar with Meshtastic?
Vaguely, but also you mentioned LoRa. That's long range radio, correct? Yeah. Okay. So so I'm a little bit familiar with Meshtastic, but tell me again what it is. Refresh.
Yeah. So Meshtastic's kind of nice because effectively it just uses the low raw radio system under the hood, where you can effectively have one. Let's not use purple. You can have kind of like one instance of something talking to another instance of something over 5 kilometers, we'll say, using using this low raw signal. No internet required, no wireless required, no Bluetooth LE kind of required. Low raw in practice is actually kind of we'll call it an ancient system. There's a few things that look really appealing. What's the thing that who's the Dorsey? Dorsey recently released something that's like bit chatter or something like that. But it's like a messaging system built on top of Bluetooth low energy.
Okay. I think I've seen things like that where it's like useful at festivals and that sort of situation where there's too many people and the network's overwhelmed, or you're in too remote of a location.
Yeah, so it's BitChat specifically. Okay. I wanted to make sure I got that right. But BitChat is kind of built on top of like the Bluetooth low energy technology to be able to send small packets of information over large distances just by piggybacking on existing Apple devices, right? Or not just Apple devices, but any device that's Bluetooth low energy enabled. It's how things like AirTag works. It's how things like a lot of other tracking pieces of technology work. So there's kind of like more modern replacements for low raw, but the thing that's nice about low raw is they've got this Meshtastic ecosystem as a very like simple starting point.
Sure, and AirTags don't have a 5 kilometer range either.
Oh, right. Yeah. So AirTag, like the Bluetooth low energy technology very much relies on people kind of being nearby, right?
Yeah.
The benefit to kind of the low raw tech is that 5 kilometer range. It's using a very lossy protocol for emitting information. So it's very important to have things set up and configured properly. But this was kind of the start to, okay, so I could get 5 kilometers out of this, right? Which if you're thinking about it in terms of like field deployments, being able to sit down and say like, okay, I want to be able to now send a message from, some random team, we'll call it team A, out in the field back to command. There's kind of this question of like, how do we get it from A to B, right? And so one option is, well, when we're quite often doing searches, we have, team B in the field. We're going to change this to CC for command center. We might have team C out in the field. We also might have team D out in the field. And so how do we kind of leverage this existing mesh network? And so as long as people are within 5 kilometers of one another, then this mesh network is actually able to send relayed messages on behalf. So no longer are we relying on like, hey, like game a telephone to literally relay this message. We can actually just propagate that information over this entire mesh network. And then as devices come and go, they can see messages and relay them accordingly. Think of it like kind of the old decentralized social media algorithm is the activity pub. I think that's what it is. Where it's kind of just trying to see like what messages have you seen, what messages do you still need.
Is there a dead letter queue equivalent? Like what happens if something gets severed?
As long as one of the nodes has the message, it should be able to relay it fine. There's ways you can configure it under the hood in terms of like max number of retries, like how long do you hold on to a message before you kind of improve that, or how long do you hold on to a message before you prune that? So this is kind of where some of my more kind of modern day thinking on it is there was this great, I don't even want to call it like, there was kind of this great paper from Raytheon back in 2014. It's called Data Ferrying at the Tactical Edge. Awesome paper. It was kind of funny because I came across it in the early days of building this project. And as I'm going through the paper, I see like this picture of somebody with a Raspberry Pi with their Ethernet cable wired all the way out to a LoRa antenna. And so you kind of see the like formings of this ecosystem back in 2014 from like a more military perspective, right? Well, the way that they dealt with this in kind of the Raytheon system was they had your team-based ecosystem, but then they put like a drone overhead that is kind of like effectively ferrying information, right? Like this had a low raw antenna attached to it. It had a little bit more storage. And so then if say like team A was out of range of C or B, team A instead could relay up to the drone, which then as it's flying its flight pattern around the search area could relay the message back to command on your behalf. And then you factor that in with multiple drones and everything being connected with the low raw mesh network, and cool, like data's propagating fine, like it's getting all out and about. Apologies for my horrible drone drawing. There's a reason I'm not in graphic design these days.
It conveys what it needs to.
Right. This is not a UFO. So that was the kind of like basic idea of like, how do we kind of take this idea of, data ferrying and being able to leverage drones and not necessarily get rid of our, not necessarily get rid of their existing use, but augment them with newer capabilities. So that way we can use smaller pieces of tech out in the field. Weight is like very much a big concern when it comes to these items. Like when we're carrying stuff in the field, like our packs were 20 pounds ish on a regular. When we did training, we had to do it with 25 pounds or 30 pounds. I can't remember. That's how long it's been since I had to do a training session. And then the drones themselves, we were like, okay, well, keeping weight low at the edge, a DJI Mini is like 250 grams, right? In addition to like the small server processing unit, that came out to less than a kilo. And so we're not really talking about adding that much weight onto an existing pack. It's really just a matter of like augmenting an existing individual with some additional capabilities. So it wouldn't fully remove the need to kind of send a team out into the field. I'm a very big proponent of human in the loop type of stuff. And so I wouldn't necessarily rely on just kind of strict automation going out and doing this. Especially if you find someone hurt, you need to be able to act fast, not necessarily wait for, emergency rescue to come out and about to find you. During initial scoping of the area, sure, like we can automate a lot of that. But when it comes to the actual like dispensing of care, there's essential human in the loop kind of interactions there.
Yeah, you mentioned like the weight of 1 kilo against the pack weight of like a little around 10 kilos, it sounds like.
20 pounds,
so is that,
ish.
Is that kind of the ratio, like that each person would have 1 drone? So for every rescuer, there'd be a drone? Like one of these.
You could have like really just like 1 person on each team. Like, right, a lot of it kind of comes down to how many people are going to be comfortable operating drones at the end of the day. My hope would be to fully automate kind of some of the drone use eventually, where people aren't necessarily driving the drones so much, but the drones are helping people know where to look, catching things that people are missing, or even just helping like augment and inform them out in the wild. Some other things we deal with is usually like dangerous wildlife, poisonous plants, snakes, you kind of name it. And so just more eyes is usually better, especially when you've been out there for a few hours. Your eyes get fatigued very fast, and it gets hard to locate and identify like what you're looking for and even what you're looking at sometimes.
Is there any value in having like different types of eyes, like infrared cameras or other types of vision systems that can see things human eyes can't?
Yeah, to some extent. There's also problems though where like digital systems fail. I did a man tracking course, and so I joke about it as like I can probably beat you in a game of hide and seek, right? Man tracking teaches you how to look for the subtle differences in the ground, in the things people step on, and how to track people through wilderness. It's a relatively small group of individuals with that level of expertise these days. But there's a lot of value in being able to have an actual set of eyes that aren't impacted by the light. Infrared is great, but infrared's not going to see like the moisture on the bottom of a rock that's been kicked over after a rainstorm, right? That's something that like only people are really gonna to know to look for. A camera might be able to see a broken branch, but they wouldn't be able to tell, is that branch broken from somebody stepping on it, or is that branch broken from somebody intentionally trying to mislead someone or redirect them off the path. So there's kind of a lot of the essential human in the loop type of tasks that like, while yeah, adding more technology and more sensors would be great, I think one of the downsides that kind of comes along with it is the fact that it adds more cost, it adds more weight every time you add a new camera or a new lens. And when you add more cost and more weight, it makes it harder for volunteer groups to afford, right? Like there's a reason why like a lot of them don't have the big drones today. There's a reason why a lot of law enforcement have those, but they have larger budgets and are able to operate on that pretty quickly. But in terms of like a search and rescue capability, like very few folks have actual drones.
You kind of showed us. So what actually made the cut? What is involved in sort of your this is what's needed package?
The what's needed package. That's an interesting one. So the what's needed package very much boiled down to like the edge unit. And then as long as you had a drone that would allow you to send the video feed to a media server, which a good number of them do, if you look at kind of a lot of the FPV drones out there, like those are sending to media servers that people are recording. There's a lot of like public video content out there from that kind of a perspective. And so having kind of just any drone use as a video was kind of like I didn't want to be opinionated about the drone, right? Kind of to the point that I made earlier of like government kind of has its preference and its technologies that get used, especially even within like the volunteer organizations. They're pretty opinionated about what you're allowed to use and what you're not allowed to use. So very much like my current implementation exists as a test bed, right? It proves out the concept, it shows that this can be done, but in terms of like actually productionizing it and going through the process of getting it in the hands of actual users, there's still kind of like a long way ahead of us in terms of like finding vetted tech, pulling some of that vetted tech together, figuring out what the right way to use all of that is, so on and so forth. And I think one of the big benefits to the ecosystem is like the technology it's using, it's using old tech, right? Like before the days of LLMs, like it's using classic computer vision modeling that has backed a lot of like popular solutions in the past. Not specifically for this area, but in other areas of like taking video and doing real-time processing and being able to identify what's on it. The big benefit is that it moves us out into the field so that way you don't have to rely on that active internet connection. So that server unit, the current Mark III, which is powered by two 18650 batteries, is kind of like the quintessential, like this is at minimum what you need. I started looking at kind of like, how do I do relay nodes? And eventually I want to kind of build some of that more into a drone. But one of the benefits of the Meshtastic ecosystem is you can buy like relay nodes for next to nothing online. I think this one cost me like $100 a few months ago. It's just a LilyGo T-beam. You can set it up and configure it like any Meshtastic node, and then it will sit down and act as an actual relay. Because of it, it's actually what's this exact weight? I just took it, 85 grams. Because of how lightweight it is, it actually can be carried by something like a DJI drone. And so now you've got an easy way to say, let's spend $1,000 on a drone or a couple of drones, attach a couple of these, good old zip tie trick from the folks who have been in the military. Everything you can attach with zip ties, and then just send it out and fly it over the area that you're looking for, right? And then all of your information can actually get relayed back. But the main unit is kind of like the bread and butter, right? Like it's got a lot of heavy processing.
Can you hold that up again for us and also walk us through the hardware that's included?
Yeah, so very, very basic setup. Basic, I say. It's actually not that basic. This has actually gone through 3 iterations. So before I walk through this one, Mark I was very much just a simple file server. Used the same kind of battery system where it was powered by two 18650s. It was just like an old Raspberry Pi 3B Plus computer I had laying around. That was powered by those two. My Mark II, which had a 3D printed case. I don't have the Mark II actually fully assembled right now, but it was a Raspberry Pi 5, the Halo chip, and then the battery supply as well. So that all fit in that little box. It worked off broadcasting its own Wi-Fi network. You would just connect to that Wi-Fi network and then stream all your data. Current implementation adds onto that. So we've got the 5 as a base. We've got the AI hat as kind of like the immediate system. We've got a low raw hat. So being able to take that information and being able to send those message packets out over the low raw network. And then we've got just the power supply on the back. So this is like a very, very much a prototype of like, kind of take what I can off the shelf, assemble it together, focus on writing the software, and build it from there. The batteries.
18650 adapter. Yeah, is that something that I can buy and use for a Raspberry Pi?
Yeah, so this one is a Waveshare X1200. I'm currently on a message thread with the people that make this. It's Geekworm, I believe, is who makes this. But you can see like the GPIO pins on the bottom here that actually use to attach and power it. They document the GPIO pins. They do not document these pins. So I asked them for some clarification on what these pins are doing before I move forward with it as kind of part of the final solution. My suspicion is they're all test pads. And if you look at the test pads, it's likely they're pulling things like temperature, information about power usage and consumption. There's a whole bunch of stuff that I'm sure you can get off these test pads. I just want to know specifically what they are doing when they are reading those values. So this one cost me like, I want to say it was like $40 for the enclosure, for the battery supply itself. And then the 2 batteries, I just went to my local vape store and got the 18650s because it's important that you get the ones that are not there's two models of 18650s. There's some that let you plug in and directly charge the battery themselves. They're a little bit longer, and so they don't fit these quite the same. But when you go and like, if you're looking for kind of the shorter ones that just charge by being plugged in through the device, because this actually has like the charging capability on the board itself. These ones you can go to like like I said, your vape shop. You can buy two of them for, I think I got mine for $25, but that's a lifetime warranty. So as soon as these go bad, I take them in and I say, here, take these, give me 2 free ones, and they'll give me 2 free ones.
That's not bad.
So, I think when I was pulling together the price, I think this full unit wound up being somewhere close to just shy of $300. Manufacturer, call it $500 if I were to ever sell it. I would definitely in-house a lot of stuff. The only other thing I didn't really cover on the hardware side of things, I do have like a heat sink tucked in here. So like your just standard heat sink that's attached to the board and whatnot. But yeah, like relatively simple, I would say, on like the hardware side of things. Everything kind of built up very progressively, started small, iterated towards a solution that I found worked really well. And yeah, just kind of offers us a lot of value where we can find it.
That's really cool. Yeah. It's really, really cool. I mean, I'm like, one, just like the mesh network and that the application that you're using it for, it's just so incredible. And then I'm also just thinking of all the other things that I could potentially use both the mesh network and just like mobile compute power for.
Yeah. Well, and I was talking to one of the mentors way back when, where it's like, how long until our phone just has the processing power? Like, is building the interim device really even worth it? And I think where I end up in some really kind of like where I kind of fall in this side of the world is the Meshtastic ecosystem. While maybe not the final system I want to build on top of, I think offers kind of a little bit of benefit from the 5K distance. Obviously, that 5K is fairly nominal. Your results may vary. I was pretty impressed with the fact that I could turn on a node at my house, and then I went over to my friend's house across the other side of the neighborhood, and I was able to send a message and have it relayed all the way back without any issue. So just for some very simple,
like an Android phone with a Meshtastic radio built in.
Meshtastic has apps. The tricky thing is like the LoRa antenna isn't. I don't see the LoRa antenna in phones. Some of that is because phones in and of themselves, the LoRa antenna actually operates at different bandwidths depending on what country you're in. So like the US, I believe, uses, this one's 915 hertz or something like that. I thought it might be on the board itself, but I don't think it is. So like the US has a band, Europe has a band. So different countries have specific radio bands that they're allowed to operate in when it comes to the actual LoRa network. So that's something that you have to be mindful of. Actually, I wonder if LilyGo has it. Yeah, 915 hertz. Yeah. And so you kind of have to buy them purposely, right? And so if you did that with phones, right, then phones would have antennas that clash depending on which area of the world that you're in. And from a manufacturing standpoint, not the greatest, but like can be done kind of deal. There's actually kind of a fun tidbit of information here, which is, why in the US you're asked to put your phone onto airplane mode, but in every other country you're not?
No.
A lot of that's because the US radio band from like the flight administration side of things comes right up against the commercial phone band. And they wanted to, there wasn't enough padding or tolerance on the upper side of that band, where if there was like, say, a faulty manufacturing plant that produced radios that were broadcasting outside the the slightest bit outside the band, then it could potentially interfere with like radios on the airplane. And while that like likelihood is extremely low, they wanted to have like extra safeguards in place to prevent it from ever happening.
That's terrifying, because I imagine so many people have been lulled into a false sense of security because they're like, oh, I never turned it off and nothing ever happened.
Well, and then
Mythbusters, their phone wasn't the one that was going to trigger it.
Well, then Mythbusters Mythbusters did a bit on it too, where it's like, is this really a big issue, right? And like they kind of came to the end conclusion of like, let's like, one, it was kind of busted that like you don't necessarily need to do this. But yeah, kind of to that point of like, it's more of an extra safeguard, right? Like you want to de-risk as much as possible. And so if there's like one person that's like, screw them, I'm not going to put my phone into airplane mode. I think I've been like halfway in the air on a flight before I realized I forgot to put my phone into airplane mode. You know, slight chances of it interfering. So definitely still do it. I'm not saying not to. I'm saying you should still do it. But it was just kind of some interesting history I picked up doing some research into this ecosystem when I was trying to figure out, you know, radio band frequencies, where do they fall in the grand scheme of things. But yeah.
All right, so what's next for the project?
I mean, I've been working on like the software side of things for the longest time, I would say.
Oh yeah, that's actually, we didn't talk about that at all. What is the software stack that you're using? It's all running on Raspberry Pi, so something
yes.
compatible. Yes.
I was building the Edge system in Rust. And some of that was like the job I had previous to it was a very big Rust shop. The other part of it was when I was going and looking at it, the mechanism I used specifically for dealing with media processing is GStreamer. That's a pretty common library for doing real-time video processing and whatnot. The pipeline syntax when it comes to that system is a pain in the ass. But when I was looking at it, there was like an option for Python. There was an option for, I want to say it was Java was the other one. And then there was an option for Rust. And I was looking at this, well, you know, if I wanted to go dual purpose with this eventually, dual purpose being military applications and customers and sales and things like that, then I'd want the actual like edge infrastructure to be as secure as possible. And having a system that managed memory a lot tighter was kind of ideal. For like more of like the backend layer, I never got around to kind of having a centralized API or client-side receiver for this kind of stuff quite yet. I had not gotten far enough to kind of conceptualize what I wanted that side of the world to look like. Mobile app was all TypeScript, so being able to access it from your phone and being able to do some interactions there were all like built with not Tauri. There's a mobile variant. React Mobile, I think, was what I wound up using in the end, just because I didn't want to learn Swift or Android quite at the time and just wanted to be able to package something quickly and build a proof of concept. But yeah, my general approach is use the tool that's right for the job. Rust felt like a very natural placement here. It was definitely a pain in the butt working with at the edge layer, but in terms of like, hey, being able to compile something, have a small binary that I can then take and just drop on that machine and go, and then also know that the memory is going to be fairly well managed without needing to deal with garbage collection, pauses, and buffering and whatnot. It all worked pretty well. It wrote a lot of the data to the local card, so you could actually take the card out and like get the data off of it directly that way. Rather than trying to transmit it over the mesh network to try to send data back home, right? Like the mesh network was very much used for emergency message broadcasting. So we found this. But for like a lot of the other data that we were collecting, that just got buffered to the local device. And then, yeah, for something like the DevOpsy tooling, I was using like a little bit of Go in there, but I wasn't using Go nearly as much as I have for other projects that I've worked on. Very, very heavy on TypeScript and Rust.
Thanks. Okay, now back to what I was asking, which is
what's next? Gosh, it's a good question. I'm, given I'm unemployed, I'm just going to kind of keep pushing on it where I can. I have some promising leads already, so I'm very excited for kind of opening up those conversations and seeing where some folks want to potentially go with their projects. But in terms of like where I'm at with stuff, it's very much taken a side seat while I'm trying to get out of state. My hope is eventually to land Denver or Seattle area. We'll see what happens. And then once we've got, like, once I feel like I'm in a much better place housing wise, I'll probably look at picking it up again. I've checked both Seattle and Denver to make sure, or not Seattle and Denver, but Washington and Colorado to see if they have equivalent search and rescue organizations I can join and get involved with up there. And it seems like a promising area to go about doing it. I have thought about, I have actually, it's not today, but Monday I'm starting up my membership back at Capital Factory, which is like an innovator incubator, not really an incubator, kind of just more of a co-working space for a lot of startups here in Austin. Great place to go and network, meet people, meet investors, meet mentors, you kind of name it. And then I'll just be working down there while I'm trying to find a new job. So keep working on this, keep pushing on it where I can, maybe put an application in or two to some of the DoD programs that they have here. See what happens from those. But a lot of the folks that I've talked to about it have always been very interested in it. The problem I found, specifically the problem I found when trying to raise money around it is it's not necessarily appealing. When you talk about kind of like the reconnaissance purpose of drones in the field, like that, you see a lot of startups around. There's one out in Bee Cave here. There's Paladin out in Houston. There's a few other kind of like drone-based AI startups, or specifically drone-based search and rescue startups. And a lot of them kind of fall into the same problem line, which is like the distribution side of the world. How do you get your product out in the hands of people? And so for a lot of them, it's like, well, there's the getting stuff to the field problem, then getting it out in the hands of people, and then getting that executing. And so I very much wanted to focus on it as easy as we already have our phones out in the field. I wanted to be able to like save on the phone battery as much as I can. So that's why I thought having an extra server unit was probably the best option for us to be able to do broadcasting and being able to pull in like more video feeds into a single processing unit versus having, you know, numerous server units out in the field. Like any 4K camera would have worked. And so you can kind of think about it just like the spider web, right? Like you've got your command center, you've got your teams all out and about. Then each of the teams might have multiple drones, but one video server unit. And all of that's built on mesh, right? But yeah, finding investors was always really interesting. I'm sure there's probably some out there that are always interested in the kind of next hottest thing. I know SLMs are kind of the next thing that people are pushing on quite a bit. I don't use language models in mine at all. I kind of like the fact that it's very like classic ML kind of deal. There's a lot less hallucinations with it. Still some, because, you know, pictures are only as good as the quality that we're sent them. But yeah, just finding like an appealing use case is kind of hard. I don't know. Well, if there's people open to conversations, I'm definitely willing to have them.
We hope that happens. And if I'm ever, the spider web analogy is an interesting one, but if I'm ever lost in the woods, I really hope I get caught in this kind of metaphorical spider web. Okay. Any closing thoughts or anything you want to leave our viewers and listeners with?
I don't really know. I wish everyone the best of luck. Like, that is still looking for work. I hope, you know, I was out of work for 8 months last year. And so, you know, trying to be back on the job search. I'm definitely having like better luck around this time, but I know how hard it is. Yeah. Find a project that keeps you going, something that you're passionate and excited about, and work on that. You know, outside of this, like, I've got probably half a dozen other projects from like the analytics stack I've been working on to some of the research that I've been doing around like where I want to move, and plenty of like little one-off tools. But this has definitely been one that like I really like tinkering with, because I get to play around with software. I get to play around with hardware. My partner is actually going to teach me some electrical engineering because I need to do some soldering at some point. I've already started ideating on like, do I go full chip manufacturing side of the world? Do I outsource that? And with the 3D printer now on the way, it's like, yep, let's find some good use cases there. And I was looking up, can I 3D print silicon chips? And they're like, kinda, not quite, but kinda. And there's a few people that I was like starting to look at online last night of like, here's some good recommendations for printers. So
we did not even get into the topic of 3D printing. I also just got a 3D printer. It's one of those hobbies that begets more hobbies. So we're both gonna have fun with that.
Yeah, so this case was very much built like out of like very quick, like just wanted something that came together and worked. I spent a little bit of time working with one of the guys, like the Capital Factory has been great from like a mentorship perspective. Like I've very much enjoyed and had the pleasure of having numerous conversations with folks there. They also have a 3D print lab. So the first time I had used, the first time I had actually gone and 3D printed a case was actually with them. And it was kind of funny because I worked with them very closely to get the measurements, and the first case that came back to us were just so off. Like none of the posts were lining up right. And so I sat down one night and I'm just like, no, I'm going to sit down and like really put my mind to this, and fought in Fusion 360 for a few hours to get a model that I actually really liked that kind of adhered to what I was looking for. Got the prototype kind of built up, and when I gave it to them the next day, I'm like, just print it as is. Like I don't fuss with anything. I made sure everything was lined up right, and then sure enough, it came out and it's like perfect. Everything lined up perfect. I was able to get the screw in, no issue. I was trying to like mark and drill holes for the power supply rather than trying to like 3D model the USB-C cable connector ports out. There's a lot of like ruggedization that has to happen to the case. And so I might sit down and spend like my next couple of months working on really just 3D modeling the ruggedized case. I'm getting, my first purchase was with carbon fiber PLA. So my plan is to use that for kind of like rapidly prototyping the initial case. Obviously, it's not going to survive the heat of Texas. The heat resistance on it is not bad, but you leave that in a car overnight, or not even overnight, but just like during a hot August day, it's going to melt. And I don't want melted plastic throughout my server. So I also have like a what do you call it? A case that I have like the drone in. And so one of the other thoughts I had was like 3D printing an organizing system for the case. And so then instead of needing to have, you know, a dedicated case for the server unit, the case that I carry the drone in, I can actually like have the server unit mounted in there. And then it's a matter of just popping things out and going. But yeah, there's a lot of options there.
Yeah. Oh, well, we're going to talk more about that. Yeah, at some point.
It scratches all the engineering itches, right? A little bit of software, a little bit of hardware, a little bit of electrical, a little bit of mechanical and fabbing and whatnot. But yeah, one of the probably more exciting things I'm excited to get into is actually DIYing a drone. So 3D printing the frame and figuring out like that side of the world, and like just figuring out like how small can I make this, and also put a 4K camera on it.
I would imagine there's some sort of open source framework for the software at this point, because don't they need pretty involved control software to like account for the differences in the motors and things like that?
There's a lot of standardization.
Yeah.
And there's definitely a lot of exploration there. My dream kind of setup is eventually to have it all backed by a brain computer interface where I can just put a hat on. I was thinking about the analogy the other day of like, it feels a little Big Hero 6-ish, but still kind of fun.
But you have succeeded in bringing us back to our originally planned topic of agents and assistants. So good job there.
Eventually, I'm going to need some help trying to figure out how to code neural pathways into like, I want this drone to go up or down or side and side. And
this is a total tangent. But I saw today someone made an art exhibit that is a plant that controls a machete with its electrical signals. So it's just a plant and a potter, and there's a machete going like all over the place on a robotic arm, being controlled by the plant.
Huh.
The plant machete.
That's cool.
Interesting art exhibit. Yeah.
But yeah, like I'm pretty excited. There's a lot of pathways forward here. The biggest thing is it just kind of lets me continue to stretch my creative brain while looking for something new. So
That's awesome. We all need something
like
like that.
Sure, how to help you with that?
I didn't say your name.
That's
sorry.
she
Speaking
wants to help your creativity. She heard creativity and jumped to action. And that is the perfect conclusion to our episode on agents and assistants as an assistant butting in there out of nowhere. Next week we're going to be talking, or yes, actually next week, right? Still next week, we're going to be talking about Nix OS and home lab stuff. I have my little private EC2 behind me, 40 cores, and 100s are awesome processors.
I cannot stress exactly how much or how excited I am for that episode, because I so desperately want to convert some of my stuff over to Nix, and just haven't really had the bandwidth to sit down and play with it. I will mention the one thing I did use Nix for in this project was actually building the original operating system, because I didn't want to have to deal with kind of like the cloud init side of the world of like go and install all of this, make sure the process is installed and whatnot. I wanted a lot of that to just be baked in out of box. And so I had heard at the time that Nix can do a little bit of this. It was a lot of like experimental functionality, but I was able to sit down and actually use it to kind of create an initial package of here's everything that I want in the operating system. Locally, I was using Docker to kind of simulate some of that, but there's some hardware components like the AI chip in particular that you can't simulate on your local development machine. And so I was trying to figure out a reasonable shim for something like that.
So you weren't using Nix OS, you were using the Nix package manager on top of like Raspbian?
Yeah, effectively.
Okay, cool. All right, so yeah, that'll be next week.
It was more like starting with it was starting with Debian blank, and then adding on all the packages that I wanted to add on, copying in the binary that I had built and published, and then being able to take that and turn it into an ISO that I can then flash onto any SD card and then put into the Raspberry Pi and just be like, cool, there, it works kind of deal, right? Like,
yeah. That's awesome.
Yeah. Lots of fun things there.
Yeah. So that's really what the episode is going to be about. It's like getting things down into text, getting things to the point where they can be committed to Git. And, you know, we're not going to talk too much about AI, I promise, but it is a really great way to share context with AI agents as well.
Yeah, I had a similar experience with like Docker containers, because like a lot of my agents understand Docker Compose files fairly well. And then I kind of just give it the guidance of all of these files are used together to create one common stack locally. So don't treat them as independent things. Like they all get executed eventually, and there's some workflow components on top of that. But I imagine a lot of what I'm doing today will translate to the Nix world very, very easily and seamlessly. Yeah. So definitely excited for that one. Very much a lunch and learn kind of deal for me.
Oh, we got a comment. Nix, yes. People are excited for Nix. Thanks, James.
Nice.
All right. And with that, we'll leave you and see you all next Friday at 3 o'clock.
Yeah. Cool. Ciao.